Welcome to Chapter 15, and today we're going to talk about lipids. So, Susan, the geriatric nurse, explains to the patient the lipid panel measures the total cholesterol in his blood. So what does that mean? What is total cholesterol? Well, HDL, or high-density lipoprotein cholesterol, this is the good stuff, and it helps to clear plaque from the arteries. While LDL, or low-density lipoprotein cholesterol, this is the bad stuff, and this is what deposits the plaque in the arteries. So when talking about lipids, lipids are biomolecules that contain fatty acids or a steroid nucleus. They're soluble in organic solvents, but not in water. The Greek name for lipos means fat. Okay, so that would kind of make sense. If we think of oil and water don't mix, right? So the oil is a fat. And so that's why it's not going to be soluble in water. And lipids are an important feature in all cell membranes, fat-soluble vitamins, as well as steroid hormones. And so this would be like the kind of center, the guts of a steroid. Okay, the 3 stop signs in a house is what I call them, right? So anyway, we're going to go on a little bit further and we get to describe the different classes of the lipids. So lipids are characterized by their structures. So lipids such as waxes, fats, oils, and phospholipids, they're esters, and these can be hydrolyzed to give fatty acids and other molecules. So esters, those are going to be like ester rings, and hydrolyzed, that's a fancy word for breaking apart using water, okay? So remember, always go for those root words. Steroids are also lipids, but they do not contain fatty acids, and therefore they cannot be hydrolyzed or broken apart by water. They are characterized by the steroid nucleus of a 4-fused carbon ring. Okay, so your fatty acids here that we were talking about, these are your waxes, your fats, your oils, okay, and these are the ones that can be broken apart to give us fatty acids and other molecules. And then you have your stop signs in a house, right? So look for that backbone. And those are going to be your steroids, okay? So looking at the general structure of the lipids, again, let's branch off a little bit more. We have our fatty acids that have the long hydrocarbon tail, right? So we have long chains, like our waxes, that are going to have a long chain alcohol attached to a fatty acid. You have your triglycerides, and that means you're going to have a glycerol backbones with 3 fatty acids attached to it. Okay, so I kind of think of tri as your trigger word. Tri means 3. Okay, so look for your glycerol backbone with 3 legs, and that's going to be your triglyceride. Well, then you have these guys, right? And these are glycerol phospholipids. And this you have, again, the glycerol backbone, but only 2 fatty acids, a phosphate head, and an amino alcohol. Okay, so kind of similar structure, but completely different functions. Okay, and you have your sphingolipids, and this is your sphingoglycine, and this is your fatty acids, your phosphate head, and then it's attached to an amino alcohol. So lipids are naturally occurring compounds that are soluble in organic solvents, but again, not that water. Think of oil and water and how they don't mix. So here's a little study check for you. Lipids are characterized by the presence of fatty acids or a steroid nucleus. Which type is described by the following? Pause me and come back. So if it contains a fused 4-membered ring system or just that backbone, then that's going to be a steroid. Where if it contains that long carbon chain of the zigzags, that's going to be a fatty acid. And the ones that have the carbonyl group, those are also going to be your fatty acids. Okay? So which of the following is not characteristics of a lipid? Pause me and come back. Well, the answer is C, because lipids are nonpolar, meaning hydrophobic, and therefore they are not soluble as water. All right, great job, you guys.